So this section here will be solving equations that have fractions in them. So a little bit of review for finding least common multiples for the denominator. For instance, if you have the fractions 2/3, 1/9, 5/12, we want to try to find the least common multiple of that denominator. So we can try to find a way to cancel that out. So if we start listing the multiples of the bigger number, 12, it's 12, and then the next multiple, so 12 times 2, 24, right? So we're building up for the common multiples. 36, 48, and so on. So we start looking at these. Does 3 go into 12? Yes, it does. Does 9 go into 12? No, it does not. So we go to the next multiple, 24. 3 goes into 24, but 9 does not. So we go to the next multiple, 36. 3 does go into 36, and 9 goes into 36. So we've found our least common multiple of that denominator, or in other words, the least common denominator. Another way that you can find common multiples, besides like listing and checking, for instance, if you had 7/8, 5/12, and 11/18. See, this one's a little trickier because the multiples of 18 are more complicated and things like that. So there's a way you can do this by a prime factorization and then start building a common multiple. So like 8 could be broken down as 2 times 2 times 2, or 2 cubed. 12 is 3 times 4, or that 4 can be broken down even further as 3 times 2 times 2. So 3 times 2 squared. 18 is 3 times 6, but the 6 can be broken down as a 3 times 2. So 3 times 3 times 2, or in other words, 3 squared times 2. So those are the prime factorizations of each of those. And so you can build your least common multiple this way. Your least common multiple has to have all the factors of every number and just that kind of minimum number of time needed to have that number in it. So like 8. 8 shows up, you got to have a 2 cubed. So that's going to be in there. Then you look at 12 and you say, well, what does 12 have that's not already on the list? Well, it needs a 3, right? There's no 3 on this list, so I got to have it times 3. And then I look at the 2 squared. Well, 2 squared's already in there because of the 2 cubed, right? The 2 cubed already covers the 2 squared. All right, so then that checks off the 8 and the 12. And now we got to get to the 18. And we say, oh, what's missing? Oh, I got a 3 squared. I only have 1 3. So I've got to build that up one more to make that a 3 squared. And the 2's already covered in the 2 cubed. So now 18 is in there as well. So if you multiply that out, 2 cubed is 8, 3 squared is 9. So we get a least common multiple of 72. So those are the two methods. Usually for small numbers, I'll zoom out here real quick to show both examples. For the smaller, simpler numbers, the listing method works well. For more complicated numbers, we can kind of do this prime factor build up. So we break down those prime factors and then start creating a list that contains all of them and then build it up together. So let's do one example here from the notes to get you ready for solving the equations. So for example, we want to solve this equation for x, where we have 5x over 8 plus x over 12 equals 57 24ths. So you see, this fraction equation's pretty complicated. However, if I multiply both sides by the LCD, I can actually cancel out all of those fractions all at once. And if you kind of do the listing method, 8 goes into 24 and 12 goes into 24. So in this case here, the LCD is 24. So you can multiply both sides by 24. So you got to do that all the terms. So it's kind of like distributing on that left side. And in that case, the 8 goes into the 24 3 times. 3 times 5x would be 15x. But notice the denominator's been canceled now. Okay? And then the 12 goes into 24 2 times. Multiply what's left, 2x, so plus 2x. And then on the other side, the 24's cancel completely, so you just get 57. And now we have a much simpler equation. So let's combine like terms. 17x equals 57. Divide both sides by 17. And does that divide evenly? I don't think that divides evenly. I'm just going to grab a calculator. I'm just grabbing my phone calculator, which is often the most convenient one. 57 divided by 17. Yeah, that one does not divide, so we would just get x equals 57 17ths. And that would be our answer. Okay.